Hi everyone. Today I want to start chapter 8, which is about program control instructions. Program control instruction can direct the flow of the operation. So a portion of the program can be jumped over or it can be repeated. When you have a program without any program control instruction, then every wrong will be executed, and it will be executed only for one time in every single scan. But if you are using program control instruction, then you can use some instruction that let you jump over a specific group of instructions. Some of the line of your program can be ignored, and if you use instruction to repeat part of your program, then some part can be executed more than once. So it means that your scan time or scan cycle will be altered. So whenever you're using program control instruction, it is very important to remember that you have to think about your scan time and make sure that you are using this instruction in order to optimize your total system response and you're not making it worse. Sometimes when you are using the repeating part, you might stuck in a loop and it makes your scan cycle forever. So you cannot come out of this loop. Now let's see what are these Allen Bradley's program control instructions. We have three different program control instructions. The first one is MCR, what you can see here. The second one is the jump and label instruction. And the third one is jump to subroutine. Let's talk about each one separately. Let's talk about the first one, which is master control reset. Master control reset is similar to a fence. It fences a group of instruction, and if these group of instruction, they have an active fence, they can be executed, otherwise they were not going to be executed. So you either execute all of them or you're not going to execute any of them. Let's look at an example. Here we have a program which is using master control reset. Here is our master control reset. As you can see, the master control reset is like a fence. So it fences this part of your program. The first thing you need to know about master control reset is that our MCR is an output instruction. So you can see that MCR comes on the right hand side of your wrong, where you need to have your output instruction. And you need to have two MCR. So one of them will be the starting point and the second one will be the end point. And the second one is always unconditional. So you're not allowed to have any condition for the second one. This one is always unconditional. But the first MCR needs to have a condition. So now if this on-off switch, which is the condition of our MCR, is active, and if you have continuity over this instruction, then the program within this fence of MCR will be executed. Otherwise, it will jump to the wrong right after the second MCR. So I'm going to write what will happen based on the condition of our on-off switch. So if the bit here is equal to 1, then it means that you have continuity. And with continuity, then wrong 0, 1, 2, 3, 4, 5, 6 will be executed like this. So all these will be executed and then it will go to the wrong after the second MCR. So basically if your condition of MCR is true, then your program will be executed as normal. But if your on-off switch has a bit equal to 0, which means that you don't have continuity for the input wrong of your MCR, then let's assume that the program is here at wrong 0. Then because the MCR is not letting the program to be executed within this fence, then the program will jump to wrong number 6. So it will pass wrong number 5 and it will go to the wrong right after that. So here you can see more detail about MCR, and as we discussed, MCR is an output instruction, so you have to place them on the right hand side of the wrong. And the second one, it always comes as a pair, so you cannot have the first one and ignore having the second one. It always comes as a pair. And the second one in the pair doesn't have any condition, it's unconditional, and the first one needs to have a condition.